Welcome back to Stationeers. What I thought we'd do this episode is a bit of a binary episode. Bit of a construction episode rather than a coding episode. That's just gonna have binary on the brain from the last couple of episodes. So I'm just gonna be putting some. Well, first of all, I'm gonna put some vents down. I'll talk about some feedback, and we'll get to what's going on here in just a little while. So the feedback on binary, I should say. Yep, lots of people correctly saying yes, you can encode the value as decimal, i.e. instead of 111, I could just encode it as the number 7. And that's sort of similar to the first approach I did for my iron approach, except that I didn't bother with the whole binary side of things. Now, let's just pop down here and you'll get an idea what I'm talking about. So yes, 111 is the value 7. It's a unique value, and as long as you encode it and decode it properly, you'll get back to 111. The only reason I didn't do that and really pointed it out later, I should have realized it during the episode, but I really wanted to keep a representation of all of the switch states in the encoded value. So if the encoded value is 111, or 222 if it's on, obviously I said it's a horrible version of binary. I just want a representation that I can quickly tell at a glance, yeah, all the switches are on. Now, with switches, this is actually turned off at the moment and all kinds of different stuff on the computer, so don't worry about what things are encoded to, etc. Yeah, I wanted, because we're not going to be using switches very often, we're actually going to be tracking various values. If I can just quickly look at the encoded value and just say, yeah, I know roughly what those values are, I've set them up, so I can easily see which things are on and off, and still only using one pin, I'm happy about it. If you want to just store things as decimal instead, or rather the encoded value as decimal, that's no problem. You have to do a little bit of different code, but you're basically converting from binary into a decimal value and then back into binary again. And that's generally a lot of divisions and mods to get back to binary and separate all the variables again. Okay, so this episode, what are we actually going to be doing? Well, I think what I'd like to do is just do a lot of little building kind of stuff on this tower. 1, 2, 3, 4, 5, 6, 7. I just need to know how many active vents I've got left to go, and we're going to need a lot of pipe, because what I want to do is just start building towards building a faster alloy furnace. The trouble with Mars, and you can't really do this one on Europa. We'll have more Europa episodes to come fairly soon, but you can't really do this on Europa. On Mars, you have this day-night cycle where the temperature goes from -70 up to +20. When it's at +20, that's a lot of really nice gas we can use to extract the heat from. However, we can't just put it through typical kind of extraction of heat like an air conditioner, because it needs a certain amount of pressure to do that, and we don't have the pressure of the atmosphere. Pressure is only 2 kPa. We need a few times that to actually get the heat out of it, at least. So we're going to have to pressurize something and capture it ideally when it's up at 20 degrees, and if possible sort of process that pretty much immediately, I think. So what I was going to do, I was going to start printing these again. So I'm going to build quite a few. Well, actually, I've only got room for about 8. Yeah, only room for about 8 active vents anyway. So maybe I will just leave some of them alone. Let's just print 2 for now. Maybe 3. Let's just print 3. And I'm going to need a lot of pipe. And then what we're going to do is let's just pop over here and I'll explain. What I want to do is to take these inputs and turn them all on when it's over a certain temperature. Now we can choose whatever temperature we like there. This doesn't have to be during daytime. And in fact, you could still extract heat out of this even at this temperature, as it's going to get to like -70 or whatever it is at nighttime. There's no problem doing that, because we can get heat out of this system using the same system that we use for that temporary approach to the gas generator. So if we head over here and down here, this is I don't think this is pressurized. Let's take a quick look. Are you pressurized right now? You are pressurized, but not very high. So why don't we just grab this Okay, so this was a system that I built, and it was sort of working, sort of not. We have a lot of wall coolers and a lot of radiators. This part of the system works very, very well. It adds heat to this pipe, and that is pressurized with pollutant, which is good. So we can heat this pipe extremely well using basically everything in here. We can push an atmosphere into here, and the wall coolers will extract all the heat and send them out into this pipe, which we can then use elsewhere, essentially. So if we have this pipe network really just attached to... let's pop over here. Better at daytime, but I may well skip forward for that. But if we have that pipe network attached to the pipe network that this is currently heating, which is that tank right there, and we basically say we're going to take the atmosphere heat, we're going to push it into a block, and then we're going to pull the heat out of that block using wall coolers and push it into this pipe will get hot. That's the theory. Whether that actually works in practice is something else, but we should be able to. And you see right now it's off. I just have this switch around here that I can turn on. I'll just turn it on so you can see what the temperature is at the moment. But it heats up, let's see. Yeah, I mean 0.2 of a degree per second. So it works, but it's sort of... falling through the floor again. I really must weld that up. Yeah, there we go. Fine. So we're going to need a chamber, and I'm probably just going to need to borrow all that stuff from the other side of the base rather than run a pipe. And we'll get it over here, probably build upwards somewhere. I don't particularly need it downstairs, and I don't mind if we depressurize things when I do this. But a lot of this stuff up here isn't going to depressurize it. It's just really insulating the pipes leading to the furnace. So we shouldn't have much of an issue. So I'm going to get started, and then once I come back, I'll have at least some of the pipes sorted out, and I'll explain it a little bit further. Well, that is, if this all works. Okay, so while it's daytime, I thought I'd show you the progress so far. I've only hooked up the first 6 active vents. We've not got hooked power to them yet, but I've hooked up the pipes so you get the idea of what's going on. They're all going to be hooked up commonly to the same pipe network, but each one of these active vents is in a separate block space in the atmosphere. So depending on how good they are at pulling in atmosphere, we can imagine maybe, well, let's say if it's 2 kPa per second, then you just multiply up, and yeah, we can obviously build the tower a little bit taller. So each of those is onto a common network, which is going to come to here. And I think I've put this in this usual shape, but this is just going to end in passive vents. And we don't actually need them like this, these 3. In fact, let me just save that. Let me just save those last 3 pieces, because we're not going to need those, or those, or those. There we go. So that's going to end in passive vents. And that's going to go into this block space I'm stood in right now, because I'm going to be welding everything shut. Not that we may need this to be welded with just blocks, but it doesn't then have an explosion risk. Or well, not an implosion risk, but definitely an explosion risk in this case. And if you just have a look down here, you'll see this pipe, and this is the last section of pipe that I never insulated right here. If we just look at this, turn it on, you'll see that's at 344.7. So that is connected to our tank, which we've got downstairs. So I've got a piece of pipe going here and then up, and then this piece of pipe can go up a little bit further. And now this is where we get to how we're going to connect our, let's just go to a 4-way junction, how we're going to connect our wall coolers. So in this case, we can just go for similar kind of setup as I've got opposite here. But now we should have room for 9, depends on how we can connect the power up in here. So let's just pop this down for a second. Yeah, it really depends on how we can get the power in. So let's just put that down like this. Drop that for a second, grab our wall coolers, of which I've got a few. It's going to need a wall to put them on, isn't it? I hate it when it does that. I have pipes. They can go onto pipes. Well, in fact, no, wall coolers need to be connected to pipes. Are they just on the top? No, well, not let me without doing that. Okay, so, yep, has to connect to a surface. Fine. I've got the ability to add a surface in here now that I've finished with this bit. So let's just swap that over with our welder. Let me get to this frame. And have we got every other bit and piece needed? So I can just partially weld this up. I think so. The rest is largely going to be electric cable. You know, we can just do that whenever we need to. And we'll leave that back open, which shuts off this area. And this one. In fact, we can shut off all of these. It's all about access now. And we can get to access through the back, so that it will do fine. Okay, so how I'm going to lay these out. Let me just put the sheets away and grab that back again. Grab our tools. Let's just take that back off again. Yep, and now we're going to decide where to put the wall coolers. I think I had a common central bus before, so I may have to run it that way and then in, and that'll get us at least 7, I think, on one face of this. So let's grab our wall coolers now, and now we get the choice of where to put them. Yeah, so will I get a 7? Maybe just 6. So if I have them like that with a common pipe bus down the center, and you'll see that's obviously going down, not up. Yeah, can we actually get more than that? I don't think so. Fine, let me just spin those upside down. And let me get just one more. Okay, and then we can see how well just one sort of wall of wall coolers actually does here. I'm going to need to take those out, aren't I? And that means I need to just remap everything around here. Will that let me connect? I may have to remove that wall and then just do everything, but you get the idea. If I put our wall coolers here, not quite sure whether we're going to need, I don't need to be specific here, just use junctions like this. Not quite sure where the rest of this pipe was going to go just yet, so we can just use junctions and T-junctions, and then I can run this T-junction just as a straight piece downwards and connect into the pipework below rather than where it is right now. So I just need to do a little bit of rework, but that is something I can do off camera. Okay, so here you can see this isn't running a pollutant system because we're going to, well, I suppose we could run a pollutant system for a furnace, but CO2 is free. So this is the CO2 system and it's 341. It is gradually cooling down, as we know. So now we just need to think about cable, and that is fairly straightforward. Just I may need a high voltage cable for this inside stuff, just because they're the coolers. The active vents may not need it, and we can put them on a separate network to everything else, but we certainly have access to the heated pipe here now. So I'm going to need to go and do some electric cabling. Now, where's our closest access point? Remember, I cabled all this in heavy cable coil, even though we didn't necessarily need it, but I have it available. So where's the best place to grab our power from? I want to say back here, but this is not heavy cable coil. This is light cable coil, but we have this nice little bus here that runs in, and it's underneath, I think. Yeah, there it goes. It's going underneath. So we should be able to run that straight up the side with a relatively little cable, and then we can run it into the top. But I also want to just try and keep this on a separate network if possible, and it'd probably replace this system eventually if we can pull CO2 out of it. But for now, these are, what, 100 watts each when we turn them on? So like 600 watts drain if we grab those. And I just need to ring around a couple of levels. So ring around that level and ring around that level. And to be honest, we have cable here we can use. So yeah, I think I'm going to put them on, well, don't have to put them on a separate network, but put them on a separate network to start with and see how that goes. Okay, so I've got more of the electronics in now. I'm just going to grab a couple of switches, which I've run out of. Let's go and build those couple of switches while it's about to come daylight. Another thing that you'll see with the more recent version of the engine, you sort of see more of the hillside sort of get hit by light during the night, or, you know, as it's about to come dawn. I quite like it. It's a little bit glitchy at the moment, but I quite like it nonetheless. So, yeah, more visual effects is going to be good. Yeah, so let's get a logic switch or two built. That's going to be quite quick. And put that one in my backpack. I think I'm done with heavy cable for the moment. I'll show you what I did with it recently. I've just connected it end to end with the normal cable. Let's just turn this off. And if that causes some glitches or blowouts in power, then, you know, I can always put power controller on. I just haven't built one for now. We've just got it running behind this existing switch over here, right hand side. So this is effectively a separate power network. We've got it running all the way down there, in, up, and straight across to the wall coolers. So once I switch on that switch down there, the wall coolers can be turned on. Obviously, I've shown you the pipework. On this side, I've got a little gas sensor, which is just sensing the atmosphere right now. And then I think we're just going to put, when it lets me build a switch, do we want a lever or a switch? Let's use a switch for a change. They should be functionally identical to a lever, like a momentary switch or something. So that is fine. And let's just rename this to, let's just say active vents on. And this one, let's rename to wall coolers on. There we go. And put this away. Now, I'm missing one more step in here. I need some passive vents. And do I have any of those in my backpack? No, those are wall coolers. Do I have any passive vents anywhere? Or do I need to build them? Let's just go and stand in the appropriate place so that I can actually build them, should I want to. And let's just see what they actually take. Because it could be faster to actually build them than anything else. It needs some iron. There's some iron. Yeah, it's just faster just to build them. I only need a few. I'm going to start it with 3 and let's see how it goes. I could also rob the ones from inside the hydroponics bay. Remember, we don't really need those anymore. But this will do just fine. And I'll take the third one coming off the production line here. Much happy with this system that automatically fetches the ingots. Aside from the problem with aliases, of course, but that's a different issue for a different day. Alright, so can I now seal this up? I think I can. We may want more stuff in here anyway as time goes on, but, you know, let's get this sorted right now. So this shouldn't really have much of an effect other than drawing a little bit of atmosphere into the system. That's not going to be much of an issue. Yeah, it's 10 degrees and rising, obviously. Can I seal it? I think I can. So let me just turn it off for a second. And let's seal this in. Where is my... There we go. Alright, that should be sealed, I would hope. And let's put this back where it came from. There we go. Right, so now all I need to do is associate these switches with everything else. So I need to grab my screwdriver, and this is the wall coolers one, this is the active vent. So let's just turn this batch writer into reading the active vent, the active vent switch. Now I've got all the furnace stuff on here as well. So active vents on. Okay, and this one will be the wall coolers on. There we go. And then we're going to output it to, as you might expect, active vents, active vents. Now, if the stuff inside downstairs has an active vent, maybe that'll be a problem. but I'm not can't remember whether it does or not. But let's just change that to on and that to on. On, yeah, we've got to kind of decide what the pressure is in the room. So that's reading temperature. And we just need to turn the system on now. So I'm just going to give it a quick test. And next episode, we'll get to the electronics, assuming that this actually works. If it doesn't, I'm sure, well, I do like giving you guys something to argue about in the comments. So this should do that just fine. So there's our temperature, 285. And let me just change that to pressure. Yeah, then I can just tell what my active vents are set to. Let me turn on both of you. So active vents on. Yep, that's what happens when you attach a heavy network to a light network without putting some kind of protection between them. So all this stuff is fine until it gets to the light network, and then there's kind of problems. So yeah, we can certainly turn things on, but they will blow out cable at various points. So I'm going to go and print up some heavy cable, I think. I can't escape it by using light cable without a separate network. That said, it shouldn't be much issue to fix. I can just pull this apart temporarily, and I think I've only used light cable from here outwards. So I just need to print off maybe, I don't know, a stack of heavy cable. Will that be enough? Yeah, let's give it a try. Okay, so it's the dead of the night and I've now rewired. I've only rewired one active vent right now, but the rest obviously is just a simple extension of cable. So let's turn you on, and that is on. So the pressure is leaving the room because they're set up to the wrong setting. Now you can control those remotely, of course, but we just need to go and set these accordingly. And clicking on them should do that job. And I think I also want these two down here, and we can decide how many more of these. We just need to scale up if we want to do that. And let's turn it back on again. Are you pressurizing? Yes, you are. Okay, so let's just shift you across to, we know you're pressurizing, we don't much care at that point. Temperature, and yep, temperature is minus 70. Or 200 Kelvin. So this is about the worst time of the day to do this, but you get the idea. Let's give this a go. What we also want to be able to look at is the temperature. Now, the temperature of the tank, that is. And to do that, I don't have any way of shutting off those wall heaters right now. So it's 425, 26. I guess what I could do is just open the doors and shut them off manually. Because I can't just change that to the opposite of this, can I, at the moment? No, because just changing that to turn this off doesn't actually do anything. Although, what I could do, what happens if I do that and then reset the power switch? If I turn off that chip manually, turn it back on again, will those stay activated? I think they will. Yeah, so that's fine. I'm going to open the doors. Whoa. I just want to just turn this off entirely. Just while I'm doing that. So 427. And yes, that's going to fall a little bit, but should stabilize. Yeah, it's still depressurizing. Fine, 426. All right, let's see if we can add some heat to this now, or at least gather some heat from the minus 44 degrees that this is currently pulling in. So temperature is rising because we're pulling in atmospheric stuff at the moment. And let's turn on the wall coolers, and let's just see what happens. Now temperature is dropping. That's exactly what we want, because the temperature then should be rising in the furnace. Okay, now that's already faster than we've got with these, though of course we are essentially consuming the heat out of the atmosphere, but that's actually much faster already. What I'm wondering is just how much of a difference that's going to be during the day. Because what's going to happen is with this, we're going to have to control it a little bit differently if we want to build it this way around. What we're going to need to do is assess, and I haven't got any kind of evacuation system at the moment, is assess what the temperature is. You'll see that is... Actually, are you rising? Is that because of daytime? Yeah, so we're not robbing all of the temperature of that just yet. Let me just grab this and let's just see what the pressure is like. So pressure is building, 300. That's only from one active vent, remember, so we can do a lot better than that if we want to. And we can take this to a certain pressure, again with electronics. We'll do that next episode, if it is going to be working, that is. And we can basically pull all the heat out, and once it hits a certain value, let's say minus 50 or something like that, we can evacuate the chamber, and you can do that just by reversing the vents, I suppose. Yeah, because once it gets out in the atmosphere, that fulfills a heat sink. So during the day, we could pull in atmosphere, turn on the coolers. During the night, we could evacuate the atmosphere back out into the general atmosphere and turn off the heat the wall coolers. So I'm quite happy as a concept with that. How about all of you? Are you happy? Hopefully you are. We may need some buffer tanks, but you can see the idea. We do have an ability to heat this up at least faster than we were doing before already, and I can always add more wall coolers in there. And we're effectively heating it directly now. We don't have to have this, well, not precisely directly, but our wall coolers are directly attached to the thing they need to be connected to, which is this pipe right here. And we can just insulate this one block now, and then that pipe gets closed off completely, I think. Yeah, so I'm happy. I'll just turn this off for now because we're going to be reapproaching this with electronics later. So for now, I can shut down that and leave it shut off, which will leave our wall heaters shut off, and I'm pretty happy. Hopefully that will not mean we're using a huge amounts of power, but power's an easier one to solve. For now, I'll shut off that system and we're good to go for the next episode. So I hope you like this episode. It's been a bit of a buildy one. Thought I'd give it a bit of a change, and yes, we're going to need some power, obviously. So feel free to like, subscribe, share, as you normally would. Put comments below if you want to improve the system before we get to the electronics. But ideally, if we need a large amount of gas and pressurize that up to, like, I don't know, 10 MPa, 20 MPa in that room, we can then pull a lot of heat out, or rather a little heat out, but for a longer amount of time. So yeah, pretty good. As always, guys, nice to have you watching, and we'll see you next time for some more Stationeers.